Today we discuss technologies for energy storage that are typically used in the integrated energy systems. We particularly focused on technologies with direct integration with the electricity grids. We will take a look at some technologies that are widely used today, like pumped hydro storage and batteries. We discuss technologies which have their niche, like flywheels, compressed air, and solar thermal. And finally, we talk about technologies which are up and coming, like supercapacitors and storing of energy in molecules. We end by comparing these technologies according to their capacity and possible use. We start with the pumped hydro storage, as one of the technologies which has been around the longest. The pumped hydro storage is essentially a reservoir of water located upstream of the hydropower plant. The water from the reservoir is passed down to the turbine generating electricity, and this is how the energy is released from the storage. To store energy, we install an electric pump next to the turbine and push the downstream water back to the reservoir. This is a form of potential energy storage, as the energy is stored in the height difference of the reservoir and the downstream river. Since these reservoirs can store relatively large amounts of water at a relatively high height, we can store significant amounts of energy in the order of tens of gigawatt hours. And this method, in principle, has a large cycle efficiency of around 80%. The batteries use electrochemical reactions to store energy. There are three most common types: lithium-ion, redox flow, and lead acid. While lithium-ion and lead acid store energy in solid electrodes, redox flow batteries store energy in liquid electrolyte. In either case, the chemical nature of the constituents is changed. Energy density of lithium-ion is highest, followed by lead acid, while redox flow batteries have the lowest energy density among the three. The capacity of the lithium-ion battery is determined by the number of lithium ions that can be moved between the electrodes, while its rate of change depends on the current density that can be maintained in the electrodes. A redox flow battery is different from the other two types of batteries, as its energy storage can be decoupled from the electrodes. With redox flow, the electrode reactions determine the power of the battery, while the amount of liquid determines how much energy the battery can store. In general, this makes it easier to store large amounts of energy. However, the energy density of the liquid is very poor, resulting in a large storage footprint. Let's take a look at the compressed air storage. This is a kind of storage that is built in connection to the electricity generation process. In this case, the excess energy is used to compress air to higher pressures, and when this energy is needed, the pressure is released. The compressed air has so far been used to aid the fuel burning process in the natural gas power plants and raise their efficiency. Typically, underground salt caverns are used to store the air. Due to the temperature effects on compression and expansion of air, the storage capacity is more complex to calculate. Energy can also be stored in the form of heat. This approach is used with the solar thermal power plants. The energy of the sun is reflected by the mirrors to a collector, and this collector contains a medium, molten salt, which has very good thermal properties and can keep the heat overnight. The heat from the medium is used to produce steam and run the generator to produce electricity. The challenge of this technology is that thermal storage has a small energy density and requires large volumes. Flywheels store kinetic energy in their rotation. They are mechanical devices placed in vacuum so to minimize friction losses. They are typically used in applications in which electrochemical storage might create safety concerns, for example on aircrafts and spaceships. They have high efficiency rate of around 85%. Supercapacitors are essentially large capacitors which store energy in the electric field. The free electrons are collected on one electrode as the energy gets stored and released as the capacitor is discharged. The big advantage of a capacitor is that it can generate an enormous amount of power. Unfortunately, only for a short amount of time, since the amount of energy it can store is limited. In this slide, we can see the comparison of different energy storage technologies which we mentioned, according to their capacity and the rate of discharge. What we notice is that some technologies are more suitable to provide storage at short timescales, while the others are more suitable for longer timescales. In a renewable-rich energy system, there is an opportunity to mix and match more of them together. We also notice in the upper right corner the conversion of electricity into gas and fuel. Although such conversion was technically feasible in the past, only with the large increase of renewable power it became much needed. We consider such conversion as emerging storage option since it will be deployed in large numbers in the future. In conclusion, we have discussed various storage technologies and reflected on their characteristics. We discussed the storage technologies in the use today and the upcoming storage technologies. Some of them, like batteries, are suitable for daily fluctuations, while others, like conversion of electricity to gas, are more suitable for seasonal fluctuations of sustainable power.